Hello, I'm Tyson, your avatar.
If you work with geospatial data in Python, routing calculations are often a key step in your analysis pipeline. In this video, I'll show you how to generate routes using casaGeoTools and here services. We will look at 3 simple examples: batch routing, comparing routing strategies, and generating alternative routes. First, we import the required Python packages and initialize the casaGeoTools client. We start by importing the required Python packages. Besides standard libraries like Pandas, Shapely, and GeoPandas, we also import Folium, which we use to display the routes on interactive maps. Next, we adjust the Pandas display settings. This ensures that the notebook shows all rows and columns of the result tables, which is useful when we inspect routing results. Next, we define the origin and destination locations that we will use in the routing examples. Now we initialize the casaGeoTools client. The API key is loaded from a local.env file, which keeps credentials separate from the notebook. Once the key is loaded, we create the casaGeo client, which allows us to send routing requests. Next, we define several geographic points using Shapely. These points represent our origin and destination locations that we will use in the routing examples. In the first example, we demonstrate batch routing. We calculate routes from one origin location to 3 different destinations. For this, we create a data frame where each row represents a routing request. Each entry includes the origin, the destination, the routing mode, and the transport mode. The routes are generated using the routes batch function. casaGeoTools processes all rows in the data frame and returns the results as a geodata frame containing the route's geometries. Finally, we visualize the routes on an interactive Folium map. Each route geometry is added to the map as a GeoJSON layer, making it easy to inspect the results. In the second example, we compare the fastest and the shortest route between the same locations. We calculate 2 routes between the same origin and destination. One route is optimized for fast travel time, while the other is optimized for the shortest distance. This allows us to see how the routing strategy influences the result. Both routes are again displayed on an interactive map, allowing us to compare the paths visually. Let's have a look on the map and zoom in. The red route represents the fastest option, which primarily follows the motorway. The purple route shows the shortest path, which instead uses regional and federal roads. Finally, we request several alternative routes and visualize them on an interactive map. In our example, we set the parameter alternatives to 3. It can be set up to 7 additional route options. The routing service only returns alternatives if they represent meaningful route variations. Now, let's see the results for our example. Here we receive 4 routes in total, the main route and 3 alternatives. In this case, the alternatives appear around Hamburg. So we zoom into the city to examine the different route options more closely. You've now seen how to perform routing analysis in Python using casaGeoTools and here services. This approach makes it easy to integrate routing directly into data science workflows, notebooks, and geospatial analytics pipelines. If you want to learn more, check the documentation and tutorials in our casaGeoTools Academy.